In this lesson, I'll show you 4 more examples on how to convert equations from polar to rectangular form. The question asks, convert the polar equations to a rectangular equation in x and y. Let's start with A. In A, we have r is equal to 4. This is telling us that we have a circle of radius 4. The circle centered right in the middle. To go from polar coordinates to rectangular coordinates, we use these two formulas mainly. With that being said, we have r is equal to 4. All we have to do is replace r with the square root of x squared plus y squared. So we have the square root of x squared plus y squared is equal to 4. Now our equation is exclusively in terms of x and y, which is what we want. As an added step, you can square both sides, where we end up with x squared plus y squared is equal to 16. And this is an equation of a circle of radius 4. Let's move on to question B. In question B, we have theta is equal to 3 pi over 4. Once again, going back to these two equations, I can substitute 3 pi over 4 into theta, where I have 3 pi over 4 is equal to arctan, that's another way of saying tangent inverse of y over x. You can eliminate tangent inverse by taking the tangent of both sides, where we have tangent 3 pi over 4, and taking the tangent of an inverse tangent means that it goes away. Tangent 3 pi over 4 can be evaluated on your calculator. Tangent 3 pi over 4 is equal to negative 1. This part has become negative 1 is equal to y over x. Solving for y, we end up with negative x is equal to y. This is a linear equation where if we were to plot it on an xy plane, would be a line going in this direction, passing through the origin. Let's continue on with C. In question C, we have r is equal to negative 2 secant theta. Secant is a reciprocal function of cosine. In other words, secant theta is equal to 1 over cosine theta. Now, because the formulas we're working with are in terms of sine, cosine, and tangent, it's best that we switch secant with 1 over cosine. Let's go ahead and do that. We have r is equal to negative 2 over cosine theta. The next thing that I'll do is use this relationship where x over r is equal to cosine theta. All I did was divide r in both sides, and I ended up with x over r. So I'll replace this bit with x over r. And simplifying this fraction, we should end up with negative 2r over x. That being said, I can divide both sides by r, given that there's an r here and an r here. Both of these r's will cancel out. This becomes a 1. And multiplying both sides by x, we should end up with x is equal to negative 2. Whenever you have x is equal to a number, that's a vertical line. So x is equal to negative 2, if we look back at this xy plane and setting this as x and this as y as our axes, x is equal to negative 2 should be around here. So it should be a straight line going upwards, looking like that. Let's move on to question D. In question D, we have r is equal to 10 sine theta. Now, there are many ways that you can approach this question, but I think the best way is to be a little clever with your mathematics. What you can do is multiply both sides by r. So multiply this side by r and this side by r. You end up with r squared is equal to r 10 sine theta. Now, you'll notice that r and sine theta is one of the formulas. It actually equals to y. So this part can become 10y, and r squared can become x squared plus y squared. Because if you square a square root, the square root goes away. X squared plus y squared. At this point, most teachers will be content with what you've done, except if you want to take it a step further and actually understand what this equation is telling us, you can take this 10y over x squared plus y squared minus 10y is equal to 0. At this point, if I add 25 to both sides, watch what happens. This is a perfect square trinomial, which can be reduced down into y minus 5 squared is equal to 25. The reason why this equation is better than what we had originally at this stage is because this is an equation of a circle. Its radius is the square root of 25, that's 5. Its center would be at 0 and positive 5. So looking back here, 0 and 5 is this point right here, and whose radius is 5. So this can be represented as the radius, and the circle would look like this. And there you have it. 4 more examples on how to transform equations from polar to rectangular form.